Hi, this is Chencheng Wang, a PhD student at the University of Oslo. And today I'm going to talk about diabetes and how could stem cells help. So in 2016, the US FDA approved the first insulin pump that can automatically monitor the glucose, supplying insulin when the blood sugar are high and cut off the insulin supply when the sugar levels start to drop. When I was talking about my research with a student at the University of Oslo, I was being asked a question. You say the automatic insulin pump works quite well, why we have to still working on making beta cells? I was surprised and delighted about her knowledge was updated with all those exciting achievements. And then I start to tell why we still need research on beta cell regeneration. It is my great honor and pleasure to share the idea with you today. So this is a recently launched movie named Greenland, and the family will be transferred to a safe place and trying to escape a disaster. And when the plane was just going to leave, and they found that they forgot their kids' insulin. And it's quite reasonable that they might forgot something somewhere. However, type 1 diabetes cannot survive long without insulin supply. And you can imagine that it will be never easy to enjoy a really normal life. So again, this graph published 2 months ago shows that the average life lost in type 1 diabetes patients is 7.8 years long. So it's quite a lot. So, by the way, if the audience unfortunately have diabetes, the situation will be better if we have a good daily glucose management. So the best glucose sensor on the market tells the glucose level every 5 minutes. However, the beta cells in our body sensor the blood glucose level hundreds of times in a second. Instead of daily medication, worrying, pain, why we do not just replace the lost beta cells in our body with the healthy cells, or just let them come back if we can. So I have to mention that we are not talking about inject antibiotics to cure coronavirus. So never inject an approved cell product into your body without a professional doctor's guide. So actually, it was not a new story or a crazy imagination. Back in 1938, a book was published named The Culture of Organs. To some extent, humans actually have the capacity for regeneration. For instance, specific cells such as bone marrows can reproduce blood cells. And when a small piece of liver has been removed, it can self-renew. However, humans cannot perform the same tricky of regrowing limbs as salamanders can, and unfortunately, the eyelids cannot too. This is because during the embryonic development, most of the mammal cells lost their pluripotent potential. So games changed because human embryonic cells were found in 1998. They are the cells isolated in the bloodstream, a very early stage of human embryo. One embryonic cell can self-replicate into billions of cells in a petri dish, and they have the potential to be any kind of cells in the human body. However, because of the ethical concern, generating new embryonic cells nowadays are strictly forbidden in many countries, including in Norway. 9 years later, a great scientist, Yamalanka and Zhong, find a way to reprogram the adult cells into pluripotent stem cells, and they are similar with embryonic stem cells. Nowadays, even fat cells can be reprogrammed as stem cells. You know, it's how easy to get fat cells these days. And this achievement really boosts the research of stem cell-based therapy studies. But how to generate beta cells from iPS cells is another challenge. To achieve this, we have to learn from the body to speak the language that the cells have, to tell them, let them to be the cells we needed. So by adding chemicals, proteins, growth factors, and build up the environment the cells like, and inducing different genes expressions sequentially, like this slide shows, step by step, we can eventually get insulin-produced cells within 30 days in a petri dish. So this slide on the left side shows how the islets grows in our lab, and the video on the right side shows how the insulin-producing cells react with high concentration of glucose. And the shining moment means the cells are taking up the calcium and pushing out the insulin. So in 2002, one of the most famous scientific journal, Science, on their cover page published how people's imagination at that time the bionic human will be like in the future. That is the beginning of regenerative medicine. As science moving forward, ideas changes now. This is expectation in 2016 of how regenerative medicine looks like in the future. And we will replace the unhealthy part in our body with a more natural solution. So the gift of insulin and insulin pump transformed the deadly disease into a chronic diseases which requires intensive daily management. Through changing the fuel islets, patients do not need to carry a pump every day while skiing, camping, or swimming. And they do not need to do extra exercise as you and I did every day, and they do not need to worry about diet and blood glucose every now and then. So achievement are continually making from scientists around the world and also in our lab. But methods to making beta cells from iPS cells are still not perfect enough. It's expensive, complex, and time-consuming. They have realized nowadays that it would be really interdisciplinary research to fill the gap. Luckily, experts from almost every field are gathering together to make this happen. Well, as a stem cell biologist, I'm really proud to work with Dr. Hannah and have a chance to update my knowledge by working with experts from different fields. Try to contribute to this no matter how big or small it is. In the future, picking islets for diabetes treatment will be just like picking apple, and I wish it will be a lot later than Elon Musk moving to the Mars. Thank you.